ETOPS. Extended Operations Objectives. At the end of this course, you should learn general requirements, route planning, dispatch considerations, en route considerations, polar operations. Summary. General requirements.
Basic fundamental ETOPS concept can be described as follows. For a desired route, an allowable ETOPS area of operation is determined by locating adequate airports that can be utilized as en route diversion airports. Engine and operative still air diversion distance circles are drawn around these airports such that the planned route of flight is enclosed within the circles. Sufficient fuel is carried to complete a diversion from the most critical point along the route to a selected en route diversion airport. Normally, a two-engine airplane must stay within 60 minutes single-engine flying time of an adequate airport. This rule restricts the area of operation and may result in increased route distance and fuel. For example, consider a New York to Madrid flight under the 60-minute rule. However, if an operator meets ETOPS requirements, they may fly in areas that are 120 minutes, 180 minutes, or 240 minutes and beyond from an adequate airport. ETOPS not only provides for more direct routing, it allows for route flexibility in areas with unique navigational requirements, such as the North Atlantic Track System, and in variable seasonal wind conditions. ETOPS requirements have been codified in the 2007 FAA ETOPS Rule. Advisory Circular 120-42B provides additional guidance for operators to obtain ETOPS approval. Recognizing the sound safety principles of ETOPS, the FAA regulations have been expanded to include passenger airplanes with more than two engines. For passenger airplanes with more than two engines, ETOPS begins at 180 minutes from an adequate airport. Therefore, most areas will remain non-ETOPS for these airplanes. Note that all cargo operations on airplanes with more than two engines are exempt from ETOPS rules. ETOPS operation requires two levels of regulatory approval. First, the airplane manufacturer must obtain a type design approval for the airframe engine combination. Then, the airline must obtain operational approval from their regulatory authority. Operational approval can be obtained at initial service entry of a new model using the accelerated ETOPS approval method. Type design approval is based on engine reliability, system design and reliability, and a demonstration flight test program. Engine reliability is measured by in-flight shutdown rate. For an airframe engine to qualify for 120 minutes ETOPS type design, most regulatory agencies require less than 5 shutdowns per 100,000 engine hours of operation fleet-wide. For 180-minute ETOPS, the requirement is less than 2 in-flight shutdowns per 100,000 engine hours of operation. And for ETOPS type design beyond 180 minutes, the requirement is less than 1 in-flight shutdown per 100,000 engine hours of operation for the world fleet. The airplane may require additional equipment to meet the system design and reliability standards for ETOPS. The APU is normally designed or upgraded to improve reliability and in-flight starting performance. On some models, electrical system redundancy is enhanced with the addition of a hydraulic motor generator or backup engine-driven generators to increase dispatch flexibility for ETOPS. These additional AC power sources can provide essential loads to flight deck equipment in the event of multiple primary generator failures. The highlighted flight deck equipment, for example, is available with the HMG as the only source of electrical power. Electronic equipment cooling systems are designed or upgraded for ETOPS. And cargo fire suppression duration is increased to meet ETOPS time-limited system requirements. The final step in obtaining ETOPS type design approval typically involves a manufacturer's demonstration flight test program. The flight test program verifies the airplane's flying qualities and the flight crew workload with various systems inoperative. Flight testing is also used to verify the airplane's ETOPS-related performance. Engine inoperative segments in excess of 330 minutes are typically performed on modern long-range ETOPS airplanes to demonstrate unrestricted routing capability. To obtain operational approval, the airline must show that it has operational and maintenance programs which address ETOPS requirements. This includes additional training for flight crews and maintenance personnel. The airline ETOPS operations program must include route planning, dispatch considerations, and an operations specification authorizing ETOPS. One or more operational validation flights may also be required to obtain regulatory approval. An airline ETOPS maintenance program only applies to two-engine airplanes and must include the identification of ETOPS-related tasks, an ETOPS parts control program, monitoring of the airline's in-flight shutdown rate, an oil consumption monitoring program, and an engine condition monitoring program. This program is intended to identify engine anomalies early and also reduce the possibility of a problem during a prolonged single-engine diversion. An important element of an ETOPS maintenance program is the similar task concept. If a similar task has been performed on two separate but similar ETOPS critical components, positive maintenance verification is required. This verification is to ensure that the problem has been resolved and that identical maintenance errors have not been introduced to both components. Examples of this are improper installation of O-rings on a chip detector and both engines during routine maintenance, or the removal and replacement of both the left and right engine fuel control modules. For cases where ground maintenance verification cannot be confirmed on an ETOPS critical component, in-flight verification may be performed during the non-ETOPS portion of a revenue flight.